This video is going to serve as a review of the information we have practiced in the last couple weeks with prime numbers, factorization, multiples, etc. Be sure to put the date and topic at the top of the page, and I'm calling this Prime Time Review. The essential question to guide this video is, how do we find factors and multiples, and of course, how do we use them? So this will serve as a review. All of these things should be pieces of information that you already know, but hopefully this will bring it all together in one place. Let's start with a quick review of factors and multiples. So we'll just do 2 practice questions for each of these. Take a moment and write out the factors of 16 and 15. Remember that factors are the building blocks, the things that multiply together to make either, in this case, 15 or 16. How'd you do? Hopefully you were able to find all the numbers that can be used to multiply to make 16 and 15. Now we'll do the same thing with just a couple practice of multiples. Since multiples can go on infinitely, let's just take a moment to write down the first 5 multiples of 12 and the first 5 multiples of 16. How'd you do? Right? We were just listing the first 5 for each of these numbers, but of course these would go on forever. And we use factors and multiple in varieties of ways. Sometimes we need to find the factors and multiples of a set of numbers and find out what they have in common. Right? And when we do that, we can use the cake method to find common factors and multiples. So let's review the cake method. And we'll do that by finding the LCM and GCF of 12 and 16. I have my cake method all set up here, and of course I need to first figure out what number I can divide them both by, and I usually start with prime numbers. These can both be divided by 2. Of course that means my next layer I need to show what's left when I divide both 12 and 16 by 2. I'm going to continue that process, and I notice again they can be divided by 2, leaving me with a final line of 3 and 4, and that's where my cake will come to an end. So think about how to use these numbers to find both the common multiple and common factor of 12 and 16. Take a moment, pause the video, and then we'll meet back and we'll see how we did. How'd you do? Right. The greatest common factor of 12 and 16 is 4, and their least common multiple is 2 times 2 times 3 times 4, which is 48. Of course, math is best when we can apply it to the real world, so we do have a reason that we need least common multiples and greatest common factors in real life situations. I'm going to write a couple problems, and we'll need to figure out which of the processes we need to use to solve this, whether it's multiples or factors. As a quick reminder, right, go ahead and record in your journal, in your notes, that multiples help us when we want to find when 2 or more events will happen concurrently, right? So when they're happening simultaneously at the same time. Factors are useful when we need to split items into even groups. I'm going to put up 2 word problems, and we're going to try to figure out which one is which, and then we'll remember how to solve that, just as a review. Take a moment to look at these 2 problems and record them in your journal. I know it's a lot to write. If you need to abbreviate just a bit, you can, but you really do want to have these problems in here as references. And once you have these recorded, think about which one is which. One of these is a multiples question, and one is a factors question. You can underline or circle items that might give you clues, but think about your resources, think about what we've said about multiples and factors to see which one would be used solving which technique. Hopefully you were able to notice that the first question is asking us to split something into groups, and it's therefore factors. The second is asking when 2 things will happen at the same time, when these cycles will repeat, and it's therefore multiples. If I were to work through these problems, right, I would find out that the greatest common factor of 18 and 15 is 3. So Kaylee would have 3 friends over, and they would each get 6 gel pens and 5 mini notepads. That's a lot per person. Meanwhile, the TriMet buses, we're looking for the LCM of 9 and 15, which is, of course, 45. Right? I could use whatever strategy helps me to get there, but that tells me that both the bus and the max would arrive again in 45 minutes. This unit we also talked about factoring and the distributive property and finding the greatest common factor so we can rewrite an expression in an equivalent way. For example, we can rewrite 36 plus 45 using the distributive property, something that will come in very valuable for you as we move into algebra, so we will be revisiting it at that time. But right now we just want to practice factoring out their greatest common factor. And you can use whatever method you need to find that, but the greatest common factor of 36 and 45 would be 9. And so if you recall, right, I can rewrite this with the 9 factored out in front of my parentheses. And then I can write what remains when I factor or divide 9 from 36 and 9 from 45. These two expressions are equivalent, and I can always double check that, right, by saying, oh, right, this adds up to 81. And on this side, this is 9 times 9, which is also 81. So I know those are equivalent, they're just written in two different forms. So that was something else we talked about in the last couple weeks. And lastly, we talked about prime factorization. We should be able to take the number 75 and rewrite it as a number sentence multiplying all of the prime factors that are used to make 75. So you can take a moment and go ahead and make a factor tree for 75. Ours might look different in the end, as we're going, but in the end we'll have the same factors, hopefully, prime numbers, that will multiply to make 75. Hopefully you also agree that the prime factorization of 75 is 3 times 5 times 5. But one way mathematicians like to record this is with exponents. So we're going to rewrite this with exponents. See if we remember how to do that. So take a moment and rewrite this with exponents. Hopefully we both agree that it's 3 times 5 to the second power, or 5 squared, because there were 2 5s at the end of our factor tree. And of course we can also work backwards to find the number if I give you the prime factors. So we'll just do one quick example here. So 2 to the third times 3 to the second. That can be expanded to 2 times 2 times 2 times 3 times 3, from which point I can just go ahead and multiply my 2 to the third power here. 2 times 2 is 4 times 2 is 8. My 3 times 3 was 9. So if I multiply that together, that should be a multiplication symbol, I would get 72. So that was the number I started with, and I provided you the prime factors. Of course, not everyone might have gotten that 72, so I have a little example here. And my imaginary student Thomas, who's usually really strong in math, made an error somewhere along the way and thought the answer to that problem was 36. What I'd like you to do is write down what you think he did wrong. Right? So just kind of jot down what steps you think he did incorrectly, and when we come together in class, we'll talk about what it is and see if we can help this imaginary student out. Right? So this video I know is a little bit lengthy, but the purpose was to review all the things we've talked about in this short little mini unit before we have a small assessment on this, and it's always good to have as a reference to see all the things in one place. We'll talk about these more in class tomorrow.